Hello, so today we'll be solving some questions from Codeforces round 958, which was the Division 2 contest. So let's start. So the first question is split the multiset. So in this question, we are given an integer n and another integer k. So what does this mean? The integer n essentially denotes that you have a set in the beginning as n, and the integer k denotes the operation that you can replace any element in this multiset, say a, as a sum of k as a sum of k integers which are positive. Okay, so the task is that you have to perform this operation minimum number of times to convert this into a multiset with all ones. Okay, so let's start. So it's a fairly simple question. What you can do is you can essentially replace n by n by 1 k minus 1 times and n minus k. So you can replace n by this and replace n by k with n minus 2k and another k minus 1 ones. So essentially the total number of times you need to perform this operation is essentially n minus 1 divided by k minus 1. Basically the ceiling of this operation. Okay, so this was the first question. Second question is called make majority. So in this question, you are given a binary string. Suppose this is the binary string, and in this you are allowed to do the following operation. You essentially choose a substring and you replace the substring by the digit in majority. So for in this case, if we choose the substring from 1 to 4, we have 3 zeros and 1 1, 1 1. So you can replace this string by 0, replace this substring by 0. So and if there is a tie, so for example, if there is a tie like this over here, you will have to replace by 0, replace this string by 0. That is the operation permitted. So the question is, so we have to check whether can we convert this string into whether we can convert this string into a 1 in the end by performing this operation. So the strategy to this is, so first of all, since we want 1 in majority, what we can do, we can take all the long segments of zeros and replace it with a single zero, and so in the end we will have so if we apply this on this string, we'll get something like 0 1 1 1 0 1. And now if we want to delete, and now if we want to remove any zeros, so what we can do is, so you take a string, so if in order to remove a 0, we'll need 2 ones. So we can take any string like this of the form 0 1 1 0 1 0 1 or 1 1 0, any substring in the new string like this, and apply our operation on these string. So what will this do? This can be, all of these can be replaced by 1, but the thing is, the invariant in this string is that number of ones minus number of zeros will remain same if we perform this operation. So essentially what you have to do in this question is, you take your original string, whatever it is, convert it to this special format where you compress all the substrings with continuous zeros, and after that you compress all the continuous zeros, and then check whether number of 1 is greater than 0. If number of 1s are greater than 0, then you print yes, else you print no. So that was the second question. Moving on to the third question. In this question, you are given an integer n, and you have to find the longest strictly increasing sequence such that suppose A1, A2 is the longest sequence, such that AI or AI plus 1 is equal to n for all I from 1 to k minus 1. So we have to find the longest sequence like this. So the strategy to this is, so suppose I take the number 23, which is also a test case. So 23 can be written as 10111 in its binary, in the binary string. So what you can do is, so initially, since we want it increasing, maybe we can think of choosing the choosing the first number without the highest MSB as 1. So if we choose the first number as without the MSB as 1, so it will have 7. Okay, and now what you can do is, next what you can do is, you so now the next number that you choose should have this number set to 1. uh, Definitely this bit cannot be set to 1, so this will be 0. And now we have option to either make this guy 0 or 1. We don't know about how should we choose this, but if we choose this bit to be 0 and the other two to be ones, so now all of these two number will equal to 23. But now this will also be the number which will give this will give us a 19 if I'm correct. And now what you can do, now you set this bit to 1 again and this bit to 0, so you will get 10101, which is 21. And now all of this two number is also 23. Similarly, you can set this guy to 1 again and this guy to 0. You will get 10110, that is 22. And of course 23 will definitely be an answer, and no number greater than 23 can be an answer now. So the strategy is, you look at the binary representation of the number, and keep replacing each one by zeros. So the answer will be, the length of the sequence will be number of set bits plus 1 if number of set bits are greater than 0, is greater than 1. Else, if your number is just power of 2, it's just 1 or power of 2, so something like this, so you cannot have two different numbers whose or you cannot have more than one number whose or in this sequence. So in that case, in this case, if number of set bits equal to 1, then the value of k is 1 and your n itself is the sequence. Else what you have to do, you look at the binary representation of the number, and starting from the MSB, keep switching every number to every set bit to 0, and you will get the sequence in increasing order. So in case of 23, you first set this bit to 0, then you set this bit to 0, then you set this the second last and the last bit to 0, and finally the final number, whatever it is. So yeah, this was the third question. So that's it for today. I couldn't solve the fourth question during the contest, so I won't be explaining this now.